So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to automation industry. So guys, we have started our new series regarding special mechanical devices, and in our previous session we discussed about the part feeding systems. So in that part feeding system, bowl feeder is the main important thing. So in this session we will see what are the different bowl feeder selection parameters. So without wasting time, let's get started. So how to choose the right bowl feeder component? So this is very important. So first thing is the part orientation, how the part orientation is required. Then the base unit, that is nothing but on which the vibrator unit is placed, that will be nothing but the electromagnetic device or a pneumatic device which will create the vibrations. Then the controller, so this controller is important because that will control the voltage and amplitude of the vibration. Then we have the bowl diameter, the bowl capacity, part feed rate. So let's check one by one the part orientation. Now, the orientation is nothing but controlling the attitude of the part so that they are in the correct positions when they arrive at the designated work or assembly station. So the part can be placed in a random position through the hopper, so they will get fed to the bowl feeder at a very random position. So part orientation is very important. Like this is input parameter that is required to be given while selecting the bowl feeder. We should tell the bowl feeder manufacturer that this is the orientation we want at the output. According to that, they need to design the bowl feeder. So basically we will achieve that orientation by passing the part through different obstructions. You might have seen the videos also, right? Then we can have pneumatic air jets also, which is an effective manner and can assist in some cases for orienting the parts and increasing the number of oriented parts. So so this is how the part orientation is required to be considered. Then we have the base unit. So as I discussed, the base unit is nothing but the drive unit, and this can be available in AC/DC or pneumatic system also, and it will create the vibrations, and you can see the vibrations per minute and the line frequency. So these parameters will decide how the parts are getting separated out, sorted out, and how at what rate we are getting. So that is why this base unit selection is very important. And while having selecting this bowl, first we should determine the vibratory bowl that will base suit the application, and lower the total weight may permit the use of smaller base unit for given size bowl, because the bowl size that it will be having its own weight. So that is how the first size of the bowl is important to select the unit, and choosing the bowl larger than the minimum size required will allow for more in bowl part storage and greater opportunity to orient the parts. So these are kind of tips, uh, or also these are kind of uh, parameters on which the bowl feeder selection is dependent. Then the controller, as we discussed about the base unit, so for that base unit we will need some controller. So different types of controllers are available, and they will be working on different parameters. Here we can see we have a thermostat or variable transformer. So this will vary the voltage, and it will produce the flux therefore, and will vary the voltage accordingly. So it is kind of simpler controller. Then we have electronic voltage controller. So that will uh, use this principle. Then we have analog frequency controller. So they can get a constant voltage and constant frequency, and thus they will improve the functioning. And we have a digital frequency controller. So these are kind of different controllers, and uh, Here we can see like whether high speed feeding is required, then we can have a frequency controller with the accelerometer. Then whether there is a continuous changer from set to state load, then we can have the frequency controller giving constant voltage and constant frequency. We can It might happen that in the industry there is a generator set and we have to change her from generator state to state load. So then we have heavy components leading to change in the load on the vibratory feeder continuously. So then we can have frequency control with feedback provision. And if we have a regular working not falling in either of the above three categories, then we can have a normal voltage controller. So uh, depending on these conditions we can have the controller. Then come the important factor as a bowl diameter. How to decide the bowl diameter? So this bowl diameter of a feeder, it should be at least 10 times the length of the part is to feed. Then the bowl diameter is approximately 10 times the width of the stud that it feeds, and the diameter of the vibratory feeder bowl should be minimum of 10 times the length of the part it is to feed. So these are kind of general guidelines, and we can see how the preferred part movement. Here we can see this is not preferred, this is bad. uh, Bad, this is not required. So this is the bowl diameter. Then the bowl capacity. So feed rates can be affected by the weight of the part. So Um, if the bowl is empty, the feeder's amplitude of the vibration may increase sometimes, and that can cause decrease in feed rates due to too high amplitude. So uh, capacity overload can change the ability of the parts to separate and feed. So that's why we always check on to the bowl capacity whether we are too many parts into the bowl, or we are feeding the parts at a proper levels. So that's why we can regulate these levels by having automatic storage hopper with a level control switch. So we will not be having continuously feeding the material from the hopper, but it will be having some switch that will indicate that the level is low. Then the hopper will start and again start feeding the hopper. So that is how we can control it, the bowl capacity. Then the part feed rate. So the part feed rate refers to number of properly oriented parts which are discharged from the bowl in a given period of time, and generally it is mentioned the rate as parts per minute. So there will be so many parts into the bowl feeder, and the part feed rate is very important, how many properly oriented parts it is giving in the minute. So that is dependent on configuration and mass of the parts, then amount of orientation required, whether we want a huge change in the orientation or just a small change, then number of tracks in the bowl, then type and size of the base unit, controller speed. So that controller, how we have set the frequency, the amplitude, those things will affect a lot the part feed rate, because that will affect the how the parts are getting sorted out and how they are moving along the bowl feeder. Then level of parts maintained in the bowl, whether the bowl is like over, just now we saw the capacity, so whether the bowl is like completely filled or whether it is empty. So one of the solution is to increase the output is we can have two tracks. So the output from the ball is significantly increased if we have two tracks. So this is it for our today's session, and we saw like what are the different parameters that are required to be considered while selecting the bowl feeder. So this is it, guys, and if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.